In this video, we're going to familiarize with the live stress data analysis interface, and we're going to construct the first live stress data analysis. So we launched WIBO++, and the live stress add-on is an additional pane add-on available in WIBO++, as well as the reliability growth add-on. So we're left, after launching WIBO++ and creating a project, in this case the project is called ALTA, we're left with two choices. Either we can use the project wizard, and we're going to select the live stress data analysis, or we can go straight on the folder and right click and it will call us the same folio, same live stress data. So we select this live stress data and we click next, and he asked us basically what type of data do we have. So we have a times to failure data. For this first exercise we're not going to have any suspensions, and the unit is hour, so we're happy with that, and then we click next. Next we got the stress column interface and the use level as well that needs to be defined. So for this first example, we're going to use temperature as the accelerating stress, and we're going to insert 313 Kelvin as the use level. Notice that there are also some available fields that can be manually modified if I need to insert some particular type of stress that is not included here. But these are simply the label of the column that represents the stress. They're not related to the model that we use to analyze the data. So then we click OK. And by doing that, it creates a simple sheet with one column where we're going to insert the times to failure data, and one column where we're going to insert the temperature. And we also indicated the use stress level, which is 313 Kelvin, and that can always be changed at any time. So we now shift onto another folio as we got the data onto another folio precompiled. So here we got our times to failure data, and here we got the results that we've obtained at 348 Kelvin, so 75 Celsius, and 393, which is 120 Kelvin. And as we said, our use stress level is 313. So we then left with the choice of using, as this is a single stress, we have a choice of these three models: Arrhenius iron or IPL or inverse power law, and we choose obviously the most appropriate model for this type of data. In this case, for example, we use an iron, and we use an iron log normal, and we calculate. These are the parameters of the model, and there are also some additional information that relates to the use stress level, the number of suspension, number of failure, but we don't have any suspensions. And we can see the graphs. And these are the results at use level, 313 Kelvin. These are the results at 348 Kelvin, or 75 Celsius, and these are the results at 393 Kelvin or 120 Celsius. And we can get many of the results here. Okay, so you're free to explore all the other combinations. The first one is, for example, the use level, which would be a projection of what would have been the failures if we tested all the 14 units at 330. So these are the projected results at 330. So, and we can interrogate all of these curves via a QCP. So if we want, for example, the reliability after 2000 hours, for example, at the stress level of 313, we can question using the quick calculation pad, and it will give us any results. We can give us any results with confidence bound or just medium value, and that works exactly the same in a sense as the quick calculation pad of WIBO++. And that's it.